something related to the remainder theorem is the factor theorem. In order for something to be a factor, the remainder has to be 0. So the factor theorem is really just a special case of the remainder theorem. If x minus a is a factor, that means if you plug in a into p of x, you should get 0 for the remainder. Again, you could use synthetic division to check this as well. So example 2 says, which ones are factors? You have x cubed minus 6x squared plus 5x plus 12. Above here again, I'm going to say let p of x equal this. With the remainder theorem, for a, I would plug in p of negative 1. If I do that, I would get negative 1 cubed plus 6 times negative 1 squared plus 5 times negative 1 plus 12. Negative 1 plus 6 minus 5 equals 12. And since it equals 12, oh, I made another typo. Man, I'm on fire today. This is a minus sign, right? Which would make this a minus sign right here. Oh, and it's equal to 0. So since it's equal to 0, this means x plus 1 is a factor. Could we have done this with synthetic division as well? Yes, we'd have 1 minus 6, 5, 12. We would put a minus 1 out front, bring it down, minus, bring it down, 1, multiply, add, multiply, add, multiply, add. We get a remainder of 0 as well. Looking at part B, wanting to check x minus 3. So we would plug in 3 into our equation. 3 cubed minus 6 times 3 squared plus 5 times 3 plus 12. 27 minus 54 plus 15 plus 12. And it's equal to 0 again. We just found another factor. X minus 3 is a factor as well. Once again, we could have done synthetic division. I'm just going to keep doing this as a review. If you're dividing by x minus 3, there'd be a 3 out front. Bring down the 1. 3, add, multiply, add, multiply, add. Got a remainder of 0 there as well. Part C says check x minus 4. So then you would plug in 4 into the equation. 4 cubed minus 6 times 4 squared plus 5 times 4 plus 12. 64 minus 96 plus 20 plus 12. Do our mental math skills come into play here? Yes. If you've got strong mental math skills, these can go a lot quicker. Adding these together, we're going to get 84. 96 minus 96 is 0, once again. So x minus 4 is a factor as well. Are they all going to be factors? Does it always work? No. When we get to part D, oh, I was going to do synthetic division again just so that we keep with the same process. We have 1, negative 6, 5, 12. We're dividing by x minus 4, so positive 4 out here. Bring down the 1, 4, add, sure enough. We get a remainder of 0 with synthetic division as well. Oops. And then part D. Hopefully they show us an example where 1 doesn't work. We're checking x plus 4. So we plug in p of negative 4. So you get negative 4 cubed minus 6 times negative 4 squared plus 5 times negative 4 plus 12. Negative 64, 16 minus 96 minus 20 plus 12.
Sorry for the interruption. We are going to start calling the award winners. We'll start with last year's grade 9 award winners.
So this is
Special award winners.
not a factor.
Please go to your marshalling area in the band room hallway and meet your supervisors. Thank you.
All right, they're not calling us yet. I'll tell you that 10A and 12 are going to be your questions, but I want to show you something interesting with this question. So we found out there was 3 factors. Our original equation was x cubed minus 6x squared plus 5 times x plus 12. And we found out that x plus 1 was a factor, x minus 3 was a factor, and x minus 4 was a factor. And so in a sense, by finding all 3 of those factors, we've factored this completely. Does it make sense if you multiply 2 of these factors together, you get an x squared? And then if you multiplied by another x, you would get an x cubed.